Hi, today we are going to see about a binary search tree, that is BST. Uh, in this binary search tree, our operation we are going to do is insertion and transfers and insertion transfers. Both the operation we are going to do. Insertion means we can. This is a type of tree. Binary search tree is like this. This is one of the example of binary search tree. In this, you have seen that initially the root value is 5, and it has two children. That is left child and right child. They has both. They has both childs. That is left child and right child. So in this also every child has another, that is it can have almost two child, that is in certain situation it can has one child, or in certain different condition it has two child, and in another condition that it has no childs. So this is the binary search tree, and how the insertion process will occur means initially you will give a number data, and the data is compared first with the root. This is the root variable, root pointer. So in this root pointer, it has some address. That address is stored in a root, that is maintained by a root pointer. And this we are checking, comparing with the root whether our given, that is user defined number, is greater than this root value. If it is greater than, it will check, it will goes the with a right child. If it is less than, it will goes with left child. See here in this 5, they have given second, that is 2. So 5 is greater than 2. So sorry, 2 is lesser than 5, so it gone with left child. So 2 is stored here, and 17 is greater than 5, so 17 is stored here, right child. And again they have inserted -4. So again it will check from first 5, it will check with 5. So 5 is -4 is lesser than 5, so it goes with left child, and there is a 2, it will check with 2. So -4 is lesser than 2, so it is again lesser than, so it will go with left child, so it goes so store in left child. See here in this 3, so it will check with initially with 5, so it will 3 is less than 5, it will goes with left child, and 2, so 2 is greater than sorry 3 is greater than 2, so it goes with right child. Same here 9, 21, and 19. So this is the insertion process, and there are three types of transfers. One is four types of transfers: in order transfers, pre-order transfers, post order transfers, and level, that is level order transversal. We are going to see the four transversal method in our code. Let us go to the code. So this is we are using a linked list concept. So we are going to use, that is creating a list called linked list called left child, that is left child pointer, and right child pointer, that is self referential structure. So the both pointers stores the address of a node. So the in the node one data variable. So totally there is two pointers and one integer variable. So our function, what are the function we are going to use have been declared. So insert transfers in order, pre-order, post-order, and level order. So in our main program, first I used a C++ program. So I will create a root. Initially root equal to null, and condition is true I have created, and choice and value initially passing the condition in while, because every times it should like a menu driven program, so it every time it prints the this menu, and it will ask the choice. So choice variable I have been created, and it will get the choice and pass into switch case. And if condition is one means that is insertion. So in that condition one, what is that initially it asks the value, that is what the value we need to store, that is whether the what the value need to be added in the binary search tree, that value we need to give. And the root is the that is pointer, and I am using here that is a recursive function here. So it calls the insert, that is insert function. In insert function it passes the that is pointer and the value what we are going to store. So in the insertion it receives the that is pointer, root and value. Initially if you create means there is no, that is root is null, so it will the pointer that is contains the null and values the user return. So if root equal to null, so initially root will be null. So it will create a one node, new node, and the new node it will allocate memory for dynamically, and the new node data we are going to store the value, that is what the value the user given, and the new node left child and right child value is null initially we are creating, and we are returning the new node address into, and we are returning the new node address though. So the new node address is stored in a root. So this is the simple. But if there is already a, that is three exits, so we should create a we are linking one value in the, that is I have shown that. See here already there is a one tree, but we are going to insert another one value. So in that case what will happen, so it will goes into insert, it will get the value and it will pass. Initially the root will be, so in this condition, in this case the root value is 5. So if you if you check so if you consider initially there is a address. So I have created some that is it has some random address, but we are considering that is simply for our convenient one address. So root is root address. It stores the address of that 5. So what will happen at initially in the insert condition? What will happen that first it will insert the root value and values. That is if you consider the 19 is the value we need to insert, so root value is initially 1000. So 1019 will be passed into the insert function. So in the insert function, what will happen is that um, so here in insert function it will receive, first it will check if root is equal to null. So in this case the root is as some that is address, that is as some address. So it fails this condition, it will goes for else if value is greater than root of data, that means value is 19. So 19 is greater than root of data, so 5. So 19 is greater than 5, yes. So it will, what will happen is that root of right child equal to insert root of right child comma value. So it calls the recursive function. Recursive function means what is that? A function. Instead, we are calling the same function. So that is a recursive function. That is according to the test value, base value. This is the base value here. According to the base value, it will return and allocate the memory, and it reserve the it allocate the memory and store the data in the insert function. That is initially it will pass the root, that is 1000. Here what will happen, in insert root of right child comma value it passing. So root of right child means root is 1000, root of right means 17. So that is 3000, the value, the address 3000 is passing. So from 5 to it gone for 17, 5 to it gone for 17. So it goes that is 1000 to 3000. So after that what will happen, it will check whether the root is the root, this now this is the root, so root is null or not. Then it will check the value. So now 19 is greater than 17, so it will go for root of right. So root is 3000, it will go for root of right means root of right is 7000. So 7000 is now root value. Now it will check whether it is a null. No, it is considering here there is no value, that is in 21 there are no left child and right child, but we are going to insert a 19 value. So it will check, so here it will check the root is null, so it is not. So it will check 19 is greater than 21, no it is less than, so it will go for left child. So it will go for left child means initially it has 0, that is null. Because why is every node is created with the one data, and initially I have shown you that data will be stored, and the left and right side are stored as null. So here it will be null. So the root value it will be assigned as null value. Now the root is again checking it is null. Yes, if it is null means what will happen, it will create a one node, and it will store the data that is 19 in this node, and it will node, and what will node, and what is that, new node left child and right child, it is null, and it return the new node address. So it will return, see here in this address it has 19 is now 19 is assigned some address, so here the 7000 means it is 8000. So 8000 it return to here, so it will come again backwards. So it will return and store in left child. See 21 of left side it will return, store 8000, and here from this it will return backwards, and from this it will return backwards, and it will return the root value, that is here root is 1000, so it will return the 1000. So this is the process, this is the regression method. So this is the process of insertion. Now this is insert method, same here for left child. Then what will happen, our next transverse method, if you give transverse method it will return the choice, that is it for this menu I am returning, that is while condition. So in order, pre-order, post order, level order, and exit from transverse menu, these are the uh, these are the transversal method we are going to see. First, in order method is what is mean by that. Um, Here in order means it will first print the left last. It will goes for the last, and it will first it will print left child value. Then it will print the it will print that is root value and right child value. So LRR. So first it will check the, let us see the code. First, what is that? I am passing, that is a root, that is I am passing a function, that is calling the function in order. We are passing a root value address. So in order, the first it will check root is not equal to null. So it should be root is not equal to null, because root, if root is null, so it is there is no values, there is no tree. So root is not equal to null means in order of root of left child. Then see out root of data in order of root of right child. This means first it will call in order of root of left child. So it will check root is not equal to null. Then in order of root of left child means left child address is 2000. 2000 it will pass to the, again it will call the in order. So it will check it is not equal to null. So it is not equal to null, and then it will pass the root of left, that is first it will goes here, and it will pass the root of left child. So it will pass here, that is 4000 it will pass, and it is not null, and the root of left child, in this left child is null value. So it has null value, so null value is storing in left child. So it will again it will check the root of left child is null, so not equal to null, because it is null. So the condition fails, and it will print the next, what is that, next statement is c out of root of data. So here the root value, in this the root value is 4000. Here the root value is 4000. So 4000 of data is minus 4. First it will print minus 4, then it will check the right child. It has no right child, then it will return from the here, that is it will return here, and the left child is finished, then it will check, it will print the 2. So it will print the 2, so it will print the 2, then it will goes for right child, and it check the whether it's a left child or there. So it is not as left child, it will print 3, and it will check right child. It has no right child, then it return back to here, and it will return here, and it will print the 5. See here, it will check first, it will check the left value, that is left child, and it after that is it will goes up to the end, and it will after finishing left child, it will print the root and our right child, and it return back. So in this left child process is over. Now the root value is 5, so it printing 5, and right child value is 17. So in this 17, left child value is 9, left child is null. So 9, then 9 it will print, then the 9 right child is null, it will, then it return back here, and it will print 17, then 17 left child is right child is 21, then 21 left child is 19, 19 left child not there, and it will print 19, and it goes back, and it will print 21, and it right child is 22, and 22 left child is not there, then it will print 22, and 22 right child is not there, so it return back here. So this is in order transversal. Is for pre-order pre-order transversal. In pre-order transversal is what is that? First, same like in order transversal, but we are only changing the code. That is first in order transversal, we are first checking that it is recursively going with left child, and we are printing that root of data, and in our then right child. So first left child up to the last it will check, and it will, if there is the root value is not null, it will goes in that root, it will print the root of data, and it will check the right child. If there is no right child means it will go outside of the recursive, that is recursive function. It will goes one by one, that is a function inside a function inside a function. So there is called a base value. The base value is null. The root should be null. The root obtain the base value means from that base value it will receive the answer for, that is it will receive the values for all function. So that is the recursive function. Here in pre-order, what is that? In in order, first we are checking the left child. First in pre-order, what is that? First even we are printing the root of data, then we are going with left child and right child. So what will happen in this means? So here first it will print the root of data, so 5. So it will print 5, then it goes with left child, then it will goes with left child, and it will check. So now this is the root. Now it will print the 2, and it will goes with left child. Now it will print the minus 4, it will goes with left child. There is no left child, then it will return, and it will check for right child. There is no right child, so it will return here, and it will check the right child here, that is right child. It will print 3, so it will check left child and right child, then it return here, and it will return here, and it will check the right child, that is it right child. So it will print the root value 17, so root data it will print 17 will be print, and it will go for left child. In that left child, there is the root value 9 will be print, it will check left child, there is no left child, and right child, there is no right child. So it will goes here, and it will print check the right child, and 21 will be print, and goes for left child, that is 19. 19 will be print, and it will check 19 is left child and right child, there is no left child and right child, and it will return here, and it will check for right child. In 22 it will print, and check the left child and right child. So this is the process of pre-order transversal. So the next is post order transversal. In post order transversal is opposite, that is last it will print the root value, first it will check the left child and right child. So what will happen, first it will goes for left child, then left child. So in this here what will happen, it will check the left child and right child, there is no left child and right child, then only it will print the root value. Now 9 minus 4, then it will return back, it will check the right child, then it will here it will check left child and right child, and it will print 3, then only it will print 2, then it will return back, and it will check the right child, and it will check the left child. Here left child and right child it will check, there is no left child and right child, then it will print 9, then it return back and it check the right child 21. Here 19, that is it goes for left child and right child it will check, then there is no left child and right child, then it will print 19 and return back, and right child in this left cell and right cell is not there, so now it will print 22 and it will return back. So while returning, that is mean that it check left cell and right cell, so then only it will print 21. So here it will return back means then now left cell and right cell are over, then it will print 17, and it return back means it check left cell and right cell, then only it will last it will print the root value 5. So this is the post order transversal, and our last order transversal is level order transversal. The level order transversal means what is that? In this, according to the left child, right child value, and we are printing the root of data. Now level order transfer is according to the level it should be print. So this is first level, so this is first level, this is second level, so this is third level, this is fourth level. So first level it has only one data, that is 5. Second level 2 1 17. Third level minus 4 3 9 21. So according to level, it first is goes here, then it will pass here, then it will goes here, then it will goes here. According to zigzag method, that is according to the levels it should print the data. So for in that condition, in that situation, we are maintaining one queue. So we are passing, that is initially we are passing the root data into queue, and that is queue function is that for first in first out, that is first inserted element in the queue it should remove as first. So that concept we are going to use here, that is we are receiving the, that is root. So root we are receiving, we are checking the whether the root is null. So null means it return nothing, that means the root is null means there is no 3. So if root is not null means I am created on square bracket for maintaining for collecting the data in a square bracket, and I am creating on queue. See here I am created on queue, that is include queue. So queue method in C++ is there in library, default library. So queue I am inserting, and the queue I am inserting as a node type. So because we are storing a address, that is pointer, so for that it has created in the form of node, and I am mentioning the variable as queue. Now queue dot push root. So push method is we know that we are pushing, that is inserting a element, that is root. So address, the root address we are inserting initially. So we are checking after inserting the queue is not empty because we are inserted root. So I am passing the condition the while the queue should not be empty. The queue is empty means it condition fails. Now what is that? Queue is not empty, and I'm creating one pointer current, and I'm storing queue of friend. Queue of friend value is first value. So in this only one value is that, first value is the root value. So root value is stored in the current. Now what will I am popping, that is I am taking the, that is removing the first value, that is root value in the queue, and I'm because I am already stored in current, so now I'm printing the current of data. So what will happen here, the first value 5 is printed. Now the next is it checking if current of left child is not equal to null, q push current of left child. If current of right child not equal to null, q push right child. That means it will check, that is root is 5000. Now current of left child is that is current is 1000. The current of left child is 2, that is not null. Then right child also not null. So this two address 2000 and 3000 is stored in queue. So it will store in queue means again it will check, that is current, that is front value. So front is now left child address, that is left child address. It will, then it will pop here, then it will print the data, and current of left child, right child, it will store here. That means what is the process means, initially we are storing this and we are printing that, then it will print, it will store left child and right child. Because it is not null, so it will store and it will print the first this, and it will pop, that is it will store in current and it will pop and it will print here. At the time what will this already print, then now current of left child or right child means, then now current of left, current value is 2000, the 2000 left or right, it will store there, that is in queue. Then it will goes here, then current of left child or right child means, then the current value 9000, 6000 and 7000. Then it will store in queue. Then what will happen? Then it will comes here. That is this will be popped. The after printing it will be popped. Then it will comes here. Then it will check left child or right child, not null. So it will leave that. Then it will, so it will leave that. Then what will happen? Then 6000, 6000 that is left child, right child, null, it will leave that. Then it will check 7000, that is it has two value. This will be, this address will be stored in queue. So after that, from one by one it will going, that one by one it going, and it will print the data and it will remove from the queue. So this is the level ordered transmission. Now let us run the code. See, first I'm going to insert the same example I'm going to try, that is initially 5 here. I'm initially I'm entering the value as first value is 5, root value is 5. Now insertion is successful. Next I'm going to insert the same, that is I'm what the example is I have showed 2 and 17, that is first I am entering 2, then 17. Next minus 4 and 3, then minus 4 and 3. Next 9 and 21, up to 9 and 21 I'm going to insert 9, 21. So we are going to pass, that is transfers one by one order, that is in order means I have said first it will print left child, that is left child, then parent root value, then right child. See here left child is initially minus 4. See here left child is minus 4, then 2, then 3, then 5, then 9, here 9, then 17, then 21. So second is pre-order. Pre-order means it will print first the root value, then left child and right child. So first it will print root value 2, then root value 2, 5, 2, then minus 4, then it will print 3, then 17 here, then 9 here, then 21. Now third is pre-order, post order. So in that first it will print the, first it will check left and right, then last it will print a root. So left and right it will check what will happen means, initially left and right means, see here first it will check the left and right, then it will print the 2. So first it will print checking the left and right, then it will print the true 2. Then it will goes here, then 4 and it will check here. Then it will print minus 4. Then it will check here by 3. Then it goes back. Then it will check here. Then it will check here 17. Then 9. Then 21. So this is the post order. Then our fourth is level order, that is by level. So you check here initially 5 first level 5, and 12 17 is second level, minus 4 3 9 21 is the third level. Up to third level only we are inserting the input. So this is the level order transversal. So this is the binary search 3 in using a C++ program. Thank you.